So, NCEA Level 2 energy. It can be a real headache, right? All those formulas, all those different situations. Well, we're going to fix that. We're going to transform all that confusion into a super clear strategy so you can walk into that exam and absolutely nail it.
All right, let's kick things off with a kind of weird question. What if all this energy stuff wasn't really about physics at all? What if it was just a big accounting system? You know, like tracking money going in and out of a bank account. That's the idea we're going to run with today.
And, that's really what energy is what we call a scalar accounting system. It's basically a currency. It's not like a force, with arrows pointing everywhere. Nope, it's just a number. And its only job is to be tracked as it moves from one form to another. Okay, so if we're going to be energy accountants, first things first, we need to know the accounts. And for NCEA Level 2 mechanics, you really only need to worry about three main ones.
So, account number 1, kinetic energy. This is your motion account. It's the energy an object has because it's moving. And the most important part of this formula? That little squared symbol on the velocity. It means if you double an object's speed, you don't just double its energy, you quadruple it. That's a huge deal.
All right, next up is our height account, gravitational potential energy. You can almost picture it like money tucked away in a high-interest savings account. It's the stored-up potential an object has just because of its position. The higher it is, the more energy it has saved up, ready to be converted. And rounding out our big three, we have elastic potential energy. This is the spring account. It's the energy you store in something when you stretch it or squash it. And that little X in the formula, that's just how far you've stretched or compressed the spring away from its normal, relaxed length.
Okay, pay close attention to this one, because this is a classic exam trap. When you're calculating the potential energy an object has on a ramp, you only care about the straight-up vertical height, h. But when you calculate the energy lost to friction as it slides down that same ramp, you have to use the total distance it traveled along the slope, d. Getting those two mixed up is one of the easiest ways to lose marks.
All right, so we've got our account set up. Now it's time for the golden rule of our entire accounting system. And understanding this is your ticket to a merit grade.
And the rule is actually super simple. In a perfect world, a world with no friction or air resistance, the books always have to balance. The total amount of energy you start with has to be the exact same amount you finish with. It might move between accounts, but the grand total never changes.
And this is a perfect way to visualize it. Just look at a falling ball. At the very top, before it's released, its energy account is 100% full of gravitational potential energy. As it starts to fall, that GPE gets cashed out and deposited directly into its kinetic energy account. By the time it's about to hit the ground, the transfer is complete. It's all motion, no more potential. See? The books are perfectly balanced.
Now this is absolutely crucial for your exam, so listen up. To get merit, it's not enough to just do the math. You have to tell the examiner what assumption you're making. You need to write down this phrase or something really similar to show that you understand your calculation only works in this perfect ideal system.
But we all know we don't live in a perfect, frictionless world, right? So to get that excellence grade, we've got to face reality. We have to deal with the messy stuff, like friction.
So what happens when you actually run the numbers in the real world? When you check the starting balance, you check the ending balance, and they don't match up. There's a shortfall. Where did the energy go?
Well, it went to paying a tax, or maybe a transaction fee. That's all things like friction and air resistance are. They're the universe's service charges. And listen, the energy isn't just gone. It didn't disappear. It was just converted into other forms, usually heat and sound.
And this right here, this is the key. This is the excellence equation. This is how you make the books balance in the real world. It shows that your starting energy doesn't just equal your final energy. It equals your final energy plus all the energy that was lost as a transaction fee to things like friction.
So, how do you actually calculate it? It's a simple three-step audit. Super easy. First, you calculate the total energy you had at the very beginning. Second, you calculate the total energy you have at the very end. And third, the difference between those two numbers. Well, that's it. That's the energy that was paid as a fee to friction. All right, let's actually walk through an example to see this in action. Say we've got a 10-kilo sled sitting at the top of a ramp. We run the numbers for its gravitational potential energy, and we find out its starting balance is 490 joules. Then, the sled goes down the ramp. We measure its speed at the bottom, we calculate its kinetic energy, and we find out its final account is only holding 320 joules. Uh-oh, the books don't balance.
So, what happened to the rest? Well, it's simple subtraction. We started with 490, ended with 320. That means 170 joules is missing. That's our transaction fee. That's the energy that got turned into heat because of friction. And being able to calculate and explain that, that is what gets you an excellence grade.
All right, the theory is down. We get the accounting system. Now for maybe the most important part. How do we turn all this knowledge into actual marks on your exam paper?
First, let's talk about the super common mistakes people make, the things that just throw away easy marks. Forgetting to square the velocity for kinetic energy. That's a big one. Using the wrong distance for x in the spring formula. Simple stuff, like forgetting to convert centimeters to meters. And of course, failing to write down that conservation assumption for a merit level question. Just be aware of these.
So to make sure you don't fall into those traps, here's your exam day battle plan. A simple checklist. 1. Always start with a quick sketch. 2. Always state where your zero height level is. 3, and this is important, write out the whole energy equation before you put any numbers in. 4, show you're working clearly. And 5, finish strong with the right units and sig figs. It just makes it easy for the person marking your paper to give you credit.
And folks, this slide right here, this is gold. This is basically your cheat sheet straight from the NCEA markers themselves. It tells you exactly what to do for each grade. For achieved, just do the calculation. For merit, do the calculation and add that key conservation statement. And for excellence, perform the full energy audit. Find the initial, find the final, and then calculate and explain the energy lost. It's the literal recipe for success.
Let's just step back for a second, because this is about so much more than just passing one exam. When you really get this, when you learn to think like an energy accountant, you're learning to read the fundamental currency of the entire universe. Every single thing that happens is just an energy transaction.
So I'll leave you with this question. The next time you see a ball roll to a stop or a car hit the brakes, can you be the accountant? Can you see the energy accounts? Can you track the transfers? Can you pinpoint exactly where that so-called lost energy actually went? The moment you can do that, you haven't just learned a topic for a test, you've unlocked a completely new way of seeing everything around you.